All right, so here we go. Let's see. Here's the dimensions of the sheet, and here's the box when it's all folded up. And so let's kind of figure out what happens. We're going to cut out the corners, and then isn't that going to become the bottom of the pan? And then these things go away that I'm shading, and those flaps fold up to get the sides of the box. Okay? So the first thing, what is the height of the pan? Okay, here's my sheet. Okay, there's my cutout. If I fold this up, what's the height of the box? Well, it's right there, isn't it? Yeah, it's X. The height is X. Okay. Now, let's do the length right here. This entire sheet is 16 inches, but when we fold up these flaps, we lose some distance. How could we figure out that length right there, which corresponds there? Well, the whole thing is 16, and then don't you subtract that distance and that distance? And if that's X and that X, how many X's is that? 2. So we could do 16 minus 2X. Now we just need the width of the pan. So let's see, that's going to be this side of the right there. How could we figure that out? The whole thing is 12. We fold those sides up. The whole thing is 12. How much are we taking away right there? Minus 2X. So now we have the dimensions of the box. And so if we know the 3 dimensions, we can calculate the volume, which is length times width times height. So I'm going to write X times 16 minus 2X times 12 minus 2X. Now, there's our equation. Let's graph this. So, y equals, right there, I've already entered it in. And you can see, you don't have to multiply anything out because your calculator will do it all for you. You just have to enter that in. Okay, I'm going to do a zoom 6 to reset my window, and I'm not seeing it, are you? Okay, why is mine not working here? Oh, there it is. There it is. Now, I'm looking at this. I'm thinking I saw the line come up here, and so it must have a turning point off the screen, and I saw it come down. It must have a turning point off the screen, and then I saw it go up. Okay? So we need to adjust our window. So Y min and Y max. Any ideas what to do here? Well, negative 20? Sure, negative 20. How high? How about 50? See what happens. We didn't go high enough, we didn't go low enough. Let's go back to the window. How about for the Y min? What do you think? Negative 50. Oops. And then how about for the max? 100? Okay. We didn't get it yet. Oh, we got the min. Okay, hey, notice, do you see all these, how thick that got? Do you know why it got that way? Because when you go to window, it's going negative 50 to 100 by ones. Let's go negative 50 to 200, and let's go up by 25s. Hey, we got it. That's fantastic. Okay, so I'm going to draw a little sketch of that, and it looks like it goes just like that. Now, remember the y-axis is the volume. So where would you expect the maximum volume to occur? At the relative max. But before we do that, we need to check our domain. And I'll show you why. Let's check the domain first of all. Okay. Let's figure out what is the smallest value that x can be in this equation. Okay, now think about this sheet. You're going to cut out that little corner. Can you cut out a negative distance? No, so it can't be negative. Could you just leave the sheet like this and not cut out anything? You could, it would just be flat. So what would that x value be if you just left the sheet flat? 0. So x cannot be smaller than 0, but it could be bigger, and it could be equal to. Okay. Now let's talk about what is the maximum value for this x that you can cut out. Could you cut out an x value that's 100? No, because if you cut it out at 100, it would be bigger than the sheet. Right? So, if you look here, how about look on this lengthwise? You know, the biggest that you could cut out would be if they met right in the middle, right? Right? And how long would that distance be? 8.5? Let's see, 8.5 plus 8.5 is 17. They'd overlap. What's 16 divided by 2? 8. Okay, so now let's look in the other direction. If we went 8 this way and 8 this way, they would meet in the middle. What about on the up and down? If you went 8 this way and 8 this way, wouldn't they overlap? So it must be smaller than 8. What do you think? If they met in the middle, what's that? 6, yeah. The largest value of 6, it has to be, the maximum is 6, right? Here's another way to think about it. I'm going to just draw the end of the pan right here. This is x and x. This is 12. And this distance right there is 12 minus 2x. What's the smallest value that that green line can be? 0. Right? And so you could solve this equation. 12, 2x, 6 is the biggest that it can be. Okay? So now we know that the domain is going to be, it can be 0 or bigger, and it can be 6, but it has to be less than 6. Okay? Now, what I'm going to do is I'm going to look at my calculator, and I'm going to say that there's 0. What's that x-intercept right there? 1, 2, 3, 4, 5, 6. So there's 6. The x value for this pan, or this box, has to be somewhere in that yellow area. Right? Because the x value can't be less than 0 and it can't be more than 6. And so in that yellow area, where does the maximum volume occur? Right there. So use, actually let's not do that. Let's just find the coordinate for that maximum. Okay, so second trace maximum, we want to find a left boundary, we want to find a right boundary, and we want to find the max. The x value is 2.26, the y value is 194.1 approximately. Okay. So, what's the answer to the question? What is the value of x that produces the box with the maximum volume? Isn't that the x, and that's the y? And that's the maximum, so what value of x gives you the box with the maximum value? Yeah. So we can answer, choose x approximately equal to 2.3 inches to give maximum volume. And by the way, what is the maximum volume? Isn't that the y-axis, the up and down, which says the volume? So the maximum volume is 194. What are the units on this? Well, let's see. The box was measured in inches, so this would be inches, this would be inches, this would be inches. There's 3 of those, so inches cubed. There's your answer right there.